Good morning everyone. Today my topic is about applications of electrostatics. I am Naresh from ECE section. This is a concept video of EMTL subject. So let's get into the topic. Electrostatics. Firstly, before going to know about the applications of electrostatic, we should know what is the electrostatic. Electrostatic is a branch of physics that deals with the phenomena and properties of stationary or slow moving electric charge. So it is a stationary electric charge is called electrostatic. Electrostatic phenomena arise from the forces that electric charge exert on each other and are described by the Coulomb's law. The Coulomb's law plays a important role in the electrostatic, as the Biot-Savart's law plays important role in the magnetostatics, even though electrostatically induced forces seems to be relatively weak. Here the diagram shows the example of an electrostatic forces, that is the negative sign and the positive sign attracts each other, and the positive sign that is unlike terms repel each other and the like terms attract each other. This is shown in the figure below. And the electrostatics examples, there are many examples of electrostatic phenomena. The attraction of the plastic wrap to your hand after removing it from the package is called an example of an electrostatic. When we place our hand to near to the plastic wrap, then we feel that attraction. So that this is the example for the electrostatic. And the attraction of paper to a charge scale is also an example of an electrostatic. And the apparently spontaneous explosion of grain was also and the damage of electronic components during manufacturing, photocopier and laser printer operations. Applications of the electrostatic. There are many of the applications and some of them are described in below. They are Van de Graaff generator, that is Robert Van de Graaff first built the Van de Graaff generator in the 1931. These devices are used to demonstrate high voltage due to static electricity. Van de Graaff generators utilize both smooth and pointed surface and conductors and insulator to generate the large static charges. And xerography is a dry copying technique that is based on the electrostatics. The major steps in the process involve the following steps. This is the diagram of xerography, and the steps are: in the first stage, charging the drum. We will charge the drum, and in the second step, the positive image made on drum, so that we will place a lens on the drum, and in the charge stage, toner attracted to image. So the toner is attracted to the images, and then first stage, toner is pulled from the down by highly charged paper, so that the toner is pulled off is same like applying tattoo like operation. And charging of the photoconductive drum, transfer of an image, creating a positive charge duplicate, the attraction of toner to charged parts of the drum, and the transfer of toner to the paper. These are the steps involved in the xerography. And when the third application is laser printer. The laser printer employs the xerographic process mentioned above to produce high quality images on paper. Using a laser to produce an image on the photoconductive drum, the laser printer receives output from the computer and can achieve high quality output because of the precision with the laser light can be controlled. path of laser. Here this diagram shows the laser printer. The laser is coming from the computer or laser optics, and then it is applied to a tube. Here we can see that the path of lasers and the remaining charge region. So that is the example of a laser printer. And then the fourth application is air cleaners. So another important applications of electrostatic is found in the air cleaner, both large and small. The electrostatic part of a process places exuses, that is usually positive exuse and positive charge, on smoke, dust, pollen and the other particles in the air, and then passes the air through an oppositely charged grid that attracts and remains the charged particles. The large electrostatic precipitators are used industrially to remove over 99% of particles from the stack gas expansions associated with the burning of coal and oil. So these air cleaners are to clear the dust, and this is also called as electrostatic precipitators. It is widely used in many of the electrostatics applications. So this diagram shows the electrostatic precipitator or the air cleaner. So the first air is blowed up, and then initial filter, neutral particles are removed off, and in the second stage the charge positive post charging grid is given, which is positive, so the positive signal is applied, and then collecting grid, so which are applied in the positive, this is collected in the third stage, and then after collecting all the grid, and then it gives to the final filter so that the air will be filtered off cleanly. The last and fifth application of an op-amp of an electrostatic is inkjet printers and electrostatic paintings. The inkjet printer commonly used to print computer generalized text and graphics. Hence we see that the inkjet printers is used to print the computer generated text and graphics, and it also employs the electrostatic. This printing process is also called as electrostatic. A nozzle makes a fine spray of tiny ink droplets which are then given an electrostatic charge. The nozzle of an inkjet printer produces small ink droplets which are sprayed with an electrostatic charge. The ink which is coming from the nozzle of the inkjet printer is a process of electrostatic charge. The various computer driven devices that are used to direct the droplets to the correct positions on the page. This is the diagram of the inkjet filter. Here we can see that the inkjet the nozzle is generating the ink of lightly, and then it is given to the charging electrode, and then the output of the charging electrode is going through the deflection plates, and then the inkjet printer's laser is going towards the paper, and then also for the gutter, and then this process is continuous for the ink receiver. This ink reservoir can generate the ink, so that the inkjet printer works by this operation. These are the major applications of electrostatic. So thank you.